Next, we want to add some life cycles or loads. This guy. So I'm going to bring in a load. You probably don't have this load, but doesn't matter. You can always create your own loads. So under a load, under a life cycle, you have a phase. You have to think of your board that is going through everything that will go through in its life. For example, when the board is manufactured, it will probably go through some shipping phase, right? It will go through some storage phase, and then it will go through some operation phase, and some probably maintenance phase, let's say, right? So you need to define different phases. And under each phase, you can define different events: harmonic event, random vibe event, mechanical shock event, or thermal event, right? So if your part goes through a shipping phase, probably it will go through some thermal cycling from environment. It will probably go through some random vibration from the road noise. It will probably go through some mechanical shock if the truck hits a pothole or if the package being mishandled, type of a thing. So you need to think of all of that, right, when you thinking of a life phase. So in this example, we can either right-click, load a life cycle, right, which I can bring in a life cycle. This is the water pump board that I'm trying to analyze here. Double click, and let's just wait to load that life cycle. There you go. Shipping, environmental, pumping, and filter change, which is our maintenance, right? And you can see under each of these phases, I have a random vibe in X, Y, Z direction. I have a thermal cycling. So if I double click on any of these random events, you can see this is taken directly from FedEx website, that what the random vibration will be in the Z-axis, right? If you have your loads, your vibration loads saved somewhere in an Excel format, you can directly bring them here. If not, you can just go to Edit Profile, fill these tables, and if you already have a table like this, you can always grab these nodes and modify these as well. That type of a thing. Reset. Okay. Next. Oh, and also before I go to the next one, you can always have your duration and the number of cycles of your specific load listed here. And then we can look at a thermal cycling. It's a simple one that goes from about 15 degrees to 45 degrees, I guess, in an environment, and go back down. And then let's look at environment, pumping. Well, pumping will be the operation. So this probably will be the harshest one as far as the temperature cycling goes. You can see it goes from 10 degrees to all the way to 65 degrees and come back down. One thing you need to make sure for temperature cycling, if you start with any temperature, you go up to whatever temperature, or you go down to whatever temperature, you always need to end it at that temperature that it started, because the following cycle need to start at that temperature. So that's something to keep in mind. And then when it comes down to our mechanical shock, you can again load your profile just like a random vibe or thermal cycling, or it's kind of easier to use our drop-down menu here. Choose a shape of your choice. You can do like haversine, apply, right, which has a pointy ends here. You can do sawtooth, whatever that you want, right? And then once you choose the shape that you are happy with, then you can go here and change the duration, number of cycles, of course, and the peak load, like 32 Gs and whatever. And Sherlock will automatically scale this for you. Okay, so let's just click on cancel here because we don't want to change anything. Before we run any analysis, we need to define our reliability goals. So right click, edit properties. In this scenario, this water pump board, I want it to last 4 years and 3% probability of failure. You have all sorts of different units here you can play with, but in this scenario, we want to stick with service life units of years, and reliability metrics of probability of failure percentage. Okay, so once that's defined, then we go to analysis.